A controlled demo is safe, but when AI projects hit production, they often fall apart because we treat autonomous agents like standard chat models. Writing a prompt is like handing someone a recipe. It is a set of linear instructions. For generating an email or outlining an essay, following a recipe works. Real-world agents, however, are expected to act. They query live databases, process refunds, and interact directly with unpredictable external systems. When you ask a single string of instructions to handle API delays and multi-step reasoning at scale, that linear approach will buckle. It will shatter under the pressure of real-world complexity. Surviving in production requires moving past the search for clever sentences. We have to stop thinking about instructions and start thinking about systems engineering. Building an agent is more like conducting an orchestra. It requires coordinating a system where a core model delegates tasks to specific tools, databases, and specialized subagents. This begins with the architecture, mapping exactly how data flows from a central decision maker out to peripheral nodes. Without clear design, these components will inevitably step on each other. Beyond the architecture, every tool the agent touches needs a strict data contract. The agent must provide an exact input format to receive an exact, predictable output. If those contracts are vague, the model will hallucinate the missing information. Strict schemas and clear examples force the model into the correct format, blocking its imagination when processing things like financial transactions. For an agent to act on more than just its training data, it needs a way to pull in live context through retrieval augmented generation, or RAG. This acts as a filter for the model's context. It sorts through vast external datasets, discarding the noise and passing only the highest relevant signals to the core model. If you feed an agent irrelevant information, it will confidently give you a useless answer. The relevance of this retrieved context sets the absolute ceiling for what the agent can achieve. Integrated system design, tight tool contracts, and sharp retrieval are the pillars that turn a text generator into a functioning operating system. But a system that works on a local machine often fails on the open internet. External APIs fail, networks time out, and services go down without warning. Reliability requires logic that anticipates these drops. You have to build retry loops with structured delays, set strict timeouts, and define fallback paths for when the primary plan fails. Implementing circuit breakers ensures that a single failed connection doesn't cause a cascade that takes down your entire architecture. Deploying to the internet also means preparing for active threats. A system isn't production-ready until its perimeter is hardened against manipulation. Malicious users often use prompt injections, hidden instructions meant to override the agent's core rules. If that agent has unchecked write access to a database, a successful injection can be catastrophic. Guarding against this requires strict permission boundaries and input validation. You have to catch and block malicious requests before the agent ever has a chance to execute them. Even a secure system is a liability if you are flying blind. Without detailed tracing and observability, fixing errors is just guesswork. You need a view of every tool call, every reasoning path, and every latency spike. Success should be measured by hard metrics and success rates, not just a general feeling that the model is performing better. Reliability, security, and observability are the defensive shields that allow an agent to operate safely in the wild. Ultimately, these complex systems have to serve human beings. If the user experience isn't designed for the inherent unpredictability of AI, the engineering won't matter. An agent might nail a task one day and fumble it the next. The interface has to account for this uncertainty by setting clear expectations and handling errors gracefully. Instead of a cryptic technical error, a well-designed system offers a clarifying prompt. It actively builds a bridge of trust between the user and the machine. If a user doesn't trust the tool to handle their data or follow their instructions, they will abandon it, regardless of how advanced the backend is. Transitioning to agent engineering means moving beyond simple instructions. It means architecting resilient, secure, and human-trusted systems that can actually survive the real world.